Hello everyone, welcome to R2Prof. In this video, we will discuss how to draw a network diagram and we will also learn how to find the project's critical path. So what is a network diagram? A network diagram is a visual display that captures the relationship between the activities. To draw a network diagram, we rely on nodes and arcs. Nodes are the circles and arcs are the arrows. In the project network diagram, we also use rectangles to show the start and end of the project. Another important information that we need to draw a network diagram is the precedence relationship. The precedence relationship provides us the information to draw the project network diagram. The precedence relationship determines the sequence of activities. The most common precedence relationship is when one activity cannot start until another activity has finished. Let's review an example and develop a network diagram from scratch. In this table, you see the activities of a project abbreviated as A, B, C, and so on. We have the information about the activity times in this column and their predecessor relationship. From the table, we notice that activity A and B mark the start of the project, since there is no precedence relationship here. Similarly, activity K is the last activity of this project. Based on the information in this table, we will now draw the network diagram. So looking at this table, we notice that the project starts with activity A and activity B. So we will draw activities A and B first. The next activity in line is activity C. Since activity C has a predecessor relationship with activity A, it means that to start activity C, activity A has to be completed. And we notice that we have already completed activity A. So the next activity will be activity C. Next, we draw activity D. Activity D has a precedence relationship with activity B. We will draw activity D since we have already finished activity B. The same logic applies to activity E, which has B as its immediate predecessor. For activity F, we see activity A as the immediate predecessor and we proceed to draw activity F. For activity G, C is the immediate predecessor. Since we have already completed activity C, so we can start activity G. Next, we draw activity H, which has D as its predecessor. The activity I is next to draw with A as its predecessor, and we have this information from this table. Now, if you look at activity J has three activities as its predecessors. Those activities are activity E, G, and H. Now, we have already finished activity E, activity G, and activity H. So, in this case, we draw activity J since all these activities are already completed. The last activity in the list is activity K. Activity K has activities F, I, and J as its predecessor. So these activities are already completed, so we can draw activity K. So this is how we complete the activity diagram. So in the next slide, we will learn, once we finish the network diagram, how we can find the critical path. Next, we will discuss how to find the critical path of a project. To find the critical path, let's familiarize ourselves with the definition of path and the critical path. A path is the sequence of activities between a project's start and finish, whereas a critical path is the sequence of activities between a project's start and finish that takes the longest time to complete. Now, this is important. Critical path is the one that takes the longest time to complete. In order to find the critical path, we will identify all the possible routes from start to finish. So what we will do, we will start from activity A to activity I and then to activity K. Now this is the one possible route from start to finish. This activity time is 33 weeks. How we get that 33 weeks? We add activity time for A to activity time for I to activity time for K. So AIK value is 33 weeks. The second available route is from activity A to activity F and activity K. The activity time for this route AFK is 28 weeks. The third available route is from activity A to activity C, from activity C to activity G, from G to activity J, and finally to activity K. So the activity time for route ACGJK is 67 weeks. The fourth available route is from activity B to activity D, and from activity D to activity H, and from H to J, and finally to activity K. So the activity time for route BDHJK is 69 weeks. And the last available route is from activity B to activity E, from E to activity J, and from J to activity K. And the activity time for this route is 43 weeks. Now, according to the definition of critical path, the longest path is BDHJK. That takes 69 weeks to complete. So this is how we find the critical path of a project. That's all for today. Thank you for watching and see you in the next video.